Alright, so we finally decided to start figuring out this passive crossover network that I am postulating on for a project here where we're converting a what basically was a woofer box, a single 10-inch woofer box, into what amounts to a boom box. So we've got a tweeter for the left channel, a tweeter for the right channel, and a dual voice coil woofer in the middle that handles both channels of low frequency. Yes, so this needs a passive crossover so that I can run it off of a regular amplifier without any kind of crazy wiring and nonsense. So what we have here, we're going to have on the back of this thing a terminal plate with a left and a right input, like it was, both channels will go into the same box. And then we'll have our crossovers inside the box. So this looks like a giant rat's nest right here. Well, basically what we're doing is we have power from an amplifier coming in here. It hits the network over there. Just look at this here. Look at the top side, the tweeter side. We're running a third order network. We have a 10.2 microfarad, and we have a 0.75 millihenry shunt inductor, and we have a 13, or I'm using a 12 microfarad capacitors, 2 series capacitors, 1 shunt inductor. We have some attenuation that we're going to have here. We have 4 ohm series resistor and a 4 ohm tweeter. On the bass side, we have a baffle step network to deal with the fact that the bass tends to roll around the speaker and be attenuated. So we're going to try to correct for that a little bit with this honking iron core inductor and a parallel resistor to allow more of the low frequencies into the bass side of things. Then we've got our plain old shunt, or actually series inductor, 1.7 millihenries, which is this guy here. He's got a little bit of resistance to him. The wire's kind of small, but we'll live with it for now. We got a 6.8 microfarad shunt capacitor for a second order network. So this is a third order crossover. This is a second order crossover because the woofer tends to roll off around 2000 hertz. So I figured a second order is just fine for that. Whereas this tweeter has a pretty good response. We're crossing over at 1500 hertz because this is a pretty good tweeter for lower frequencies into the 1500 hertz range. Then we have a Zobel network to try to correct for the crazy impedance issues with this woofer. So we have our 9 microfarad capacitor. We're using an electrolytic for that one. And then we have an 8 ohm resistor in series. So that's our network. So this is the inductor for the tweeter side of things, the shunt inductor. That's the series inductor for the woofer. That's the baffle step correction inductor over there. And then this capacitor is for the tweeter, and that capacitor is the shunt capacitor for the woofer. And then this resistor and capacitor is a Zobel network, which is this thing right here. And then we have a 4 ohm resistor in series with the tweeter just to burn off some power right here. The L pad is not in the network. I don't have it right now. Let's look at some stuff here. Now what I had to do is isolate this amplifier from ground because I have the oscilloscope connected to it. And I was getting ground loops through the oscilloscope probes. So we have an isolation transformer, and then I had to break the ground connection between the third pin of the plug, so there's no earth ground on this amplifier right now. My bench is of course GFCI protected, so we don't have to worry about getting shocked if there was a fault, but we had to break the ground connection of the amp so we didn't have ground loops through these oscilloscope leads. So let's turn it on. We got a signal generator here set to 1500 hertz, which is my crossover frequency. Alright, let's look at it. There's our waveforms showing up. You can see the little bit of phase shift there. I played with the polarity. play with the polarity of one driver. See if we can move that phase shift around, but it seems like it stayed in the same spot. But if we change our frequency, give it a little bit more juice. That's distorted right there pretty badly. We are measuring the output voltage of the amplifier right here, which is this measurement right here, 11 volts. This is a 25 watt per channel amplifier, so into an 8 ohm load, which this obviously isn't 8 ohms anymore, but I'd have to calculate it, but we're able to look at that. Let's just look at it when it's about 8 volts. You know, that's a good level. Okay, let's change this down a little bit. So the green trace is the tweeter, the white trace is the woofer. Oh, way down low, 9 hertz. This seems a little bit weird, but and of course I lost it. There it goes. The low frequency, of course, is way attenuated, or the high frequency is attenuated way down because of the crossover network. See our voltage up there. Let's go into the kilohertz range. So now our green trace took over because the high frequencies can sneak through the passive components better than the low frequencies. All right. This is, yeah, I can just barely start to hear it now. Around 16.3 kilohertz, I can kind of start to hear it. Yeah. And there's some distortion going on. That's interesting. See how the distortion is there? I wonder if that's just an amplifier artifact. There, it kind of went away when I turned it down. Okay, all the voltage is high, so we're probably just overdriving the amplifier. All right. Oh, really hear it now. That's 6 kilohertz. See, we're getting close to where these are almost equal. Well, now okay, where are they equal at? We have to realize though that the vertical scaling is 4x lower on the tweeter side than it is on the woofer side. (980 hertz). So that's a passive crossover. It's kind of what they do in terms of measurements, and a crude sort of description of it. But basically you're just splitting the frequencies up. Some go to the lower frequencies to the woofer, the other ones to the tweeter. We have a 3 decibel, or a 6 no, it's actually a 12 decibel per octave filter on the woofer side, and a 18 decibel per octave on the tweeter side. And I smell the hot resistor down there, so you seem to be burning off a lot of power with that. So I got to be careful. We don't want to burn our tweeters up. So that's it.